Hello, everybody, and welcome to today's presentation, The New Way of Thinking About Application Performance, Making Java Developers More Business Relevant, brought to you by Nastel. Before we get started, I'd like to take care of a couple housekeeping items. First off, I'd like to make sure y'all can hear me okay. So if you would, just send me a quick message in the chat window to let me know you can hear me okay. Great. If you have any questions for our presenters today, please post those into the questions panel so we can get to them after the presentation. If you experience any technical difficulties today, like the audio dropping out or the screen sharing not displaying properly, please post a message in the chat panel and I will work with you to resolve those issues. Lastly, on the housekeeping list, we are recording today's presentation and we'll be making it available shortly after today's event concludes. Now that we're through with the housekeeping items, I'd like to introduce our presenter, Albert Mavashem. Albert is the Chief Technology Officer at Nastel. As the Chief Architect of Nastel's suite of products, Albert is instrumental in the creation of some of the most comprehensive and advanced tools for monitoring, managing, and performance analysis of complex transactions and integrated application processes. He is an expert in Java and middleware, including IBM's WebSphere family of products, and in implementing middleware-centric architectures, helping companies achieve business agility through technology and aligning IT with business processes in the real-time enterprise. Albert is a sought-after speaker and author of numerous articles and white papers. Now I'd like to do a quick sound check for Albert. So if you would like to say hello to our audience, and audience, please let me know if you can hear Albert by posting a message in the chat panel.
Hi everybody, this is Albert. Thank you, Billy, for the introduction. Please let me know if you can hear me okay.
Awesome, looks like everyone can hear you. Well, without further ado, I'm going to turn things over to Albert to begin the presentation.
Okay, great, thanks, Billy. So we're going to start. So the topic of this talk is going to be about taking the next level beyond application performance and exploring as to what that might look like and how do we become more business relevant in this space where the fast evolving application landscape, you've got new applications, mobile, and then fast developing applications, including blockchain and other applications that are coming on board. So how do we become more business relevant, and what is the next level for application performance going to look like? Now, we all know why performance is important. And when we deal, whether it's mobile, whether it's web, or even mainframe applications, we all understand why performance is really important. There are actually benefits, and very important benefits to get that performance to where it needs to be. And especially for the dev or ops community, the most pressing issues are MTTR, mean time to repair, MTBF, mean time between failures. There's lots of different benefits, including improving team productivity. You want to focus on developing new features and work on the code, especially if you're a developer, and less really on diving into the production issues. So you want to reduce the blame and things like that. Now, on the business side, especially today, it's all about customer experience and impact on the revenue, and obviously lots of different competitive pressures. So performance is obviously very important, and we're always trying to make things as fast as possible and obviously perform and squeeze as much of that performance out of our applications. However, in my view, performance is really one part of the overall pie. So when we look at the overall pie of what I would consider quality of experience, performance is really one part of that. So as an example, if you're, it's a very common use case. I think everybody can relate to. If you go to a web page and it's very fast, but doesn't really do anything useful, while performance might be great, your user experience can potentially be very bad. So when we look at the quality of experience, we have to take lots of different things into account. Performance is one of them. Availability of things, whether it's of business services, availability of certain features within the application are very important. And then obviously, lots of businesses today are really focused around mapping out customer journey, understanding user behavior, and then deriving the business metrics that are instrumental to make actually business decisions. So as we start to going kind of up the food chain and elevating that performance, we really need to start thinking about how some of these things impact some of the fundamental business customer experience metrics. And as an example, customer journey, performance is one of them, but a lot of it has to do looking at funnels and how user behavior or how users actually interact with the applications. And a lot of that data is actually being funneled to the product managers so they can figure out what they build, where they need to focus, and what they need to improve. But the business needs to really understand how they need to improve the business, either from a competitive standpoint or from other standpoints that's important to the business. So when we look at it, the SPI, performance is really part of the equation. So going further is, especially in the complex environments, you have lots of different data sources, coming from a variety of different silos. You've got IT metrics, application metrics, you got some customer data, even from the application performance standpoint, you're collecting potentially lots of different transactions or timing information and performance information. And there's lots of different also business metrics that business is looking at. What we see more and more is really kind of a aggregation of all of these things into what we call shared metrics that the business or the stakeholders are going to have to look at in order to make decisions within the organization. So in a sense, if you have kind of a siloed based approach where, for IT infrastructure, you look at one set of things, for apps, you're looking at something else, and the customer and the business look at something else, it's very difficult to make decisions. So when we look at the shared metrics, you need to have really a one way to look at what's going on. And we're really not talking about reporting in this sense. Reporting, yes, you can generate reports and you can look at the reports, but reports are, again, in the way I look at it, is fairly static. What we really need is insight, and insight is actionable information that enables you to make decisions. So whether it's how to improve customer experience, or what features do you need to build in the application, or what kinds of provisioning and how do I need to provision my IT infrastructure in order to deliver on the business value that we're trying to do. So the more alignment you have across these different processes, the more successful you are as a business. So, and in order to do that, you need a cross integration of all these different disciplines into one cohesive picture. Now, I call this whole area kind of shared metrics. That doesn't necessarily mean you just have one dashboard. It's an aggregation of business, of a process, culture, as well as technology into a cohesive model of what's going on in the business. Now, diving a little somewhat deeper, just as an example of some of the different metrics that we're looking at, well, you've got potentially metrics coming out of application servers, you've got transactions, there could be examples of even business metrics such as example payments, orders, things like that. And again, looking at the siloed approach is obviously one way you could look at it, but ability to look at them across is becoming more and more important. Now, what we see, especially when we're dealing with, for example, some of our clients, and obviously what we see in the in overall in the industry is that there's a transition into this whole area of collect and analyze everything. So the application performance is really becoming more or less as an intelligence platform to understand not just how fast things are and where do you need to improve and how do you solve the problems fast, but now that you're collecting lots of different data, how do you actually derive business value from it? So as you know, some of these organizations like Google, Facebook, there's been a lot of discussions around how they use all of the different data that they collect about you. But businesses today harvesting or collecting all this data, but unfortunately, most of this data is completely unutilized in the sense it sits and uses a lot of storage, but is not really very useful. So you've got this push into the collect and analyze everything. So you got lots of data being stored. You've got convergence of the different disciplines because now you've got performance, you've got logs, you've got all this other metrics that you're collecting. How do you derive customer and business intelligence from it? And then the convergence of the different technologies as well. Today, more and more businesses want to be as real time as possible. So therefore, you can't just go and say, okay, we've collected all this mountains of data. Let's just do some big data analytics on top of it and figure out what happened 2 weeks ago. More and more, we need to know what's happening now. And by now, we mean right this second. And a lot of times we see that data actually has shelf life. As an example, if you go and you want to buy something on a website, and if it takes 5 seconds or 5 minutes, it is a big difference. And if you don't respond to the customer within a very short period of time, you've basically lost that customer. So in a sense, if you haven't been able to actually capture the data and analyze what that means within whatever that shelf life might be, you've potentially lost revenue and lost that customer. So data has a shelf life, and you need to be able to respond to what's going on in your business in a fairly short period of time. Now, there's obviously a lot of buzz today around machine learning algorithms and ability to harvest the data. Now, APM tools especially collect lots of data, especially about user behavior and the transactions that are happening. Unfortunately, lots of this data is somewhat unutilized. And machine learning kind of promises to take that and actually take it up a notch in the sense that you can actually harvest this data and figure out actually how you become more business relevant. Now, again, because we're talking about now that we're collecting all of this machine data, it's not just performance, but actually collecting logs and transactions all in the same fashion. You now need not just visualization or alerting tools, but you actually need to enable the data scientists. And for that, you actually need a way to query the data that you are actually collecting in your APM or operations. So there's a need for the query and analytics language that now enables folks from outside the DevOps community to actually query the data and understand what that means. So when we look at the reference architecture of what a next generation APM looks like, we kind of arriving to an application intelligence platform where app performance is really one ingredient of the whole puzzle. So if you look at, for example, on the data sources side, you've got the data sources, could be applications, transactions, and by transaction, I actually mean user interactions. So these interactions could be a person doing something on the mobile, on the web, whatever their interface points may be. You've got metrics coming up from IT and business. You've also got logs and other machine data, which could be structured and unstructured. So in order to deliver on this kind of a vision of the shared metrics, it's no longer just enough to look at one side of the equation. So essentially, your data collection is now have to be broadened out to encompass all of these different data sources. Now, what do you do with all of this data once you actually get it? And that's kind of where the challenge really begins, because not only you need to store it, which obviously requires lots of storage and lots of different processing, and that's a challenge in itself, but you also need to figure out what's happening in real time. So that's why when we're looking at this whole space of how do you derive value from the data that we're collecting, you really need to look at one side, which is streaming analytics, figuring out things that are happening on the fly, but also from the big data standpoint, ability to pretty much store and index everything that's coming in. And the reason why you want to potentially store everything is because you really don't know what you don't know, meaning at some point in the future, somebody may say, well, what happened to this and this? Or what happened to this specific customer? What happened to this order? And if you don't know, or you haven't decided to store it, you basically lost that interaction and you have no way to analyze it. So today, a company is actually pretty much storing everything. And then the question becomes, how do you make sense of it? So what we've done is we've actually put together kind of a model of what it looks like. And a lot of it actually revolves around the concept of search. And it's very similar that almost all the data that you store needs to be available, needs to be searchable. And if you combine that with things like machine learning, anomaly detection, aggregations, and even user-defined algorithms, that allows you now to expand this whole area into the realm of a data science. And essentially, at some point, it really becomes a data science problem. Meaning, from the DevOps perspective, yes, you could track user behavior, you can identify performance bottlenecks, and you can remedy these bottlenecks. But to be able to elevate it to user behavior, customer intelligence, and application intelligence, that becomes a data science task, meaning harvesting the data, whether it's a real-time or historical, and then be able to derive meaning that is either relevant for understanding how you retain your customers, how do you improve user experience, or what features do you build or not build in your application. Common example, in the mobile app, you need to be able to harvest this data in order to understand, well, is my next release of the applications in fact better or worse? Well, you need to be able to track that in order to make that determination, since you most likely won't be able to actually talk directly to your users or to your customers. And one of the things actually I want to mention on the transactions, that's one of the actually key techniques for being able to track these customer interactions. And we can look at very specific types of these instrumentation profiles and see how they actually compare to one another. So when we look at, for example, transactions and metrics and logs, and then you can have other, obviously, unstructured data, most of the way that you actually capture this data is actually very important, because each of these actually provides its own pros and cons. So for example, for transactions, most of it is actually intercept based, meaning that when so for example, whether it's a mobile or web application, you have to be able to intercept that activity of what the user is doing with your application right there when it happens. So therefore, the best method to actually capture that is through intercept. Now, there are some sampling, obviously, based transaction techniques that are available, but they're usually not very effective to gauge user experience. Now, on the metric side, most of it is actually done by sampling. So the typical like CPU memory or other types of metrics, you would typically sample it every so often, and logs are typically event-driven. However, when we look at on the transaction side and ability to track these interactions, you find that the overhead of these types of ability to actually track that is fairly high. So you're talking about from medium to high, whereas on the metric and the log side is fairly minimal. But what you get from it is typically high resolution. And when we talk about being able to track what your users or user experience and understand how do you figure out what your application intelligence or what the customer is actually doing and what the users are doing, you need that high level of resolution. Unfortunately, sampling-based metrics and logs are typically not very very useful at tracking that. So hence, transaction tracking is probably one of the best ways to really gauge what's going on with your applications. Now, transaction, again, that's a fairly broad term. Depending on what kind of application you have, transaction can mean different things. For example, a user on the mobile app swiping on the application could be a transaction. Clicking on a button could be a transaction, or paying for something is a transaction. Whereas, for example, in some of the other environments, transaction could mean actually SQL transaction or some other type of transaction. So again, all of these are transactions. You can also think of them as interactions. However, you still need to be able to take all of these things together, like transaction metering and logs, and present in one cohesive fashion. So, but what you really get with transaction is this high level of resolution, which is typically what you need in order to get that to the next level. So what I'd like to do is maybe take a minute or so, and Billy, if you maybe could take some poll questions, I think would be a good time now.
Of course, I'll start the first poll now. We're having responses come in. We're going to give you guys a few more seconds to answer. Looks like a majority of the people watching are application developers. And we're going to move on to the next poll question real quick. We're going to give you a few more seconds for responses and then show the results. And looks like a majority answered about a day a month. And we have one more poll question that I'm going to put up here. I'll give you a few more seconds to answer. And here are the results. Hey, Albert, I'm back to you now.
Okay, great. Thank you, Billy. All right, so what I'd like to do is deep dive somewhat in a little more detail on the transaction tracing and tracking. Now, I do really distinguish between the two, tracing and tracking, and the line is somewhat fine, but But there is a, and again, the way I think about this problem is fairly different. So when we talk about tracing, we're really trying to figure out and identify the problems in the application, the code, typically in the pre-production environments where you're trying to optimize your application. So what that means is you're really trying to get into the individual method calls, parameters, what's being passed back and forth, and especially in a distributed application with a microservices involved and web services involved and so on and so forth, you want to be able to see how this whole topology of the app develops, as well as its relationship to the user, right? Is how does the user interaction translate into what's happening within your application and within obviously the sphere of control that you have. But it's really all about the resolution. And when we talk about the resolution, if you're really tracking all of these arguments and things like that, you're really trying to trace things so that you can improve application performance before the application really goes into prod. Now, or at least goes live. Now, the tracking is more in the macro view. So think of it as tracing as a micro, and think of tracking as a macro. So the macro view is more about how do users engage, what is the customer journey, and you're trying to figure out where I need to improve and measure quality of experience. And a lot of it is also about extracting the business metrics. Now, if you're simply doing tracing directly and just doing the same thing for tracing at the same level of resolution and applied in the live environment, you would typically pay the high price. And it goes into the previous slide, which is the level of overhead. Keep in mind that the higher resolution of tracing that you do, the more overhead you incur on your application simply because of it is intercept based. So we would typically recommend that you go on the lower resolution on the tracing and go or actually higher resolution on the tracing and then lower resolution on the tracking. But on the tracking side is where you start answering the questions in terms of how do my users engage, what are the features that they use, what they don't use, how they engage with my application, what do I need to improve. A lot of that usage is actually by product managers and even marketing, as well as the business. And again, depending on what types of applications you develop, you will have different, obviously, types of people engaged. Now, on the DevOps side, the typical side of the equation is obviously reduction of MTTR and trying to find problems before they impact the user. So again, you can do that by tracing transactions across the whole process, meaning starting from typically where the user starts interacting with you to everything that is linked into the process of interaction with that specific application. So, and essentially you want to get away from analyzing machine data that's literally a lot of times in the logs and getting into something meaningful. Now, a lot of it is insight through analytics and automation, meaning that you probably don't want to be stuck to a screen either. You want to be notified about what's going on, but you also, especially as a developer, you don't want to be hunting through logs and spend your time in trying to understand what all the pieces that have to be looked at. You just want to be able to gain insight directly into what's going on, what the user experience is, and then everything else that's that the application touches. And again, because today lots of teams are distributed, lots of different moving parts, there needs to be a common pane of glass where somebody looks and says, here's all the pieces that I know, and here's all the pieces that I don't know. But we all need to be really working off the same kind of shared metrics, a pane of glass. So essentially, we want to get away from that manual to somewhat more automated fashion. So here's an example of how that might look like. So let's say you have an application, got different moving parts, microservices, messaging, Java, web applications. So basically, you've got instrumentation at each of these touch points. that instrumentation, most of it is going to be intercept-based. That intercepts, meaning all of these tracking events are going to be analyzed by analytics engine, again, whichever happens to be, where you do all of that, what we call a process of stitching, meaning connecting all of these asynchronous things and then creating a common model of what the transaction actually look like. What does the user journey actually look like? And essentially getting to a point where you get an actionable result versus obviously having to do this all in a manual fashion. So think of it as almost like an application sniffer in a sense. Instead of sniffing network traffic, you're really looking at, you're sniffing for user interactions. And here's an example of what it might look like. So when we look at the shared metrics, what we typically want to see, and again, obviously your application may have something different, but you typically want to understand what is the flow. Where do the customers start to interact, and how does that whole flow work throughout the whole process? So you want to understand the flow. You want to understand kind of from a geo perspective how different, and especially if we're talking about web or mobile applications, how that works out from the geo perspective. And then combine that all with also business metrics to tell you, well, how much revenue or how many people dropped out, how many payments that have failed and things like that, again, depending on what you're actually doing. But it's the concept of bringing all of these things together in the one cohesive picture versus having to look at 5 different ways to actually do that. So you start with the shared metrics, but in order really to do that, you need to really have the proper collection and proper platform, which we talked about before, that can actually analyze all this thing and actually put it all together. So this becomes very important. Now, the health bars are typically, you want to have something that annotates and tell you where the problem areas are, where the hotspots are. Otherwise, it would be just no way to understand what's going on. And here's a specific use case. So you've got a user interaction. You want to be able to understand where that user interaction breaks. So here's an example of a breaking user interaction where you're not only capturing, and again, when we use like IT metrics or business metrics, they don't have enough resolution to be able to tell you which specific interaction or transaction that has a problem and where in the process do you have a problem. That's typically a fairly time-consuming task that I know myself. I do development, and I have a team of people, and it's a fairly tough task, simply because there's thousands of requests. They get mixed with all these other services, and it's very tough to really untangle this whole web. So you want to be able to track these interactions and pinpoint and say, well, yes, we have this problem. Well, where's the problem? And now be able to drill down in specific transaction. The key is here, this is an interesting part, is that when we're tracking transaction, it's not just about performance. The payload becomes very important. And the reason is because a lot of times the problems that are happening are all about the data or the context. So you can have one transaction that completed successfully, yet another that did not. What is the difference? Well, the difference could be that it could be geolocation, it could be other things, or it could be that there is a difference in the payload. For example, in HTTP, a different query string, or the different web page, or they could be submitting a different data into your application. So you need to be able to capture what that payload is, because without payload, just performance may not be enough. So for example, in this example of a payment, if a payment is slow, let's say a payment took a long time to complete, and one payment is $1,000 and another payment is $100,000, you would probably want to know that a $100,000 transaction or $1 million transaction is at risk versus a $100 transaction is at risk. Now that information is actually in the payload, and that's something you would want to search, or you would want to know. So transaction tracking allows you to actually uncover a lot of that resolution that we talked about, that allows you to peek at the lowest level of exchange between users, applications, and the server side components, and that becomes very important from the problem determination, but also from the data science point of view. Imagine when we talked about the whole data platform, if you're storing and indexing all this data, now a data scientist can come in independently and harvest this data to now gain insight into what the users are doing, what kind of data are they sending, what kind of, for example, in the case of a payment, what kind of payments are you processing, and then create all kinds of interesting business metrics that could be very important to the business. So again, capturing that data becomes very important, and becomes very important as a secondary for the data science to be able to harvest it. And then as we go next is, now that the infrastructure pieces are kind of opened up, and now from the developer and operation standpoint, you can know what you need to do. However, from the line of business side, they're not necessarily going to understand all of the application pieces, and they may not even care. So in order to become more business relevant, we need to start including business objectives into this equation. Now, what are some business objectives? Well, it could be an SLA. That's a simple, it could be an OLA, operational level objective, or it could be other types of objectives, like, for example, a transaction has to complete by a certain time. It could be monetary types of objectives. So the idea is to now elevate the infrastructure application interaction model or user interaction model into a service model that allows us to understand how the different services, the business services, interact and whether we're meeting our business objectives. That allows us to now take the APM or application performance and really raise it and become an application and user intelligence platform or business intelligence platform. Now, I know some of the BI tools are also tasked with that. However, most of the BI tools today are harvesting typically data that's somewhat stale. They go to large Oracle databases and they mine all this data, present all these reports. It's not as dynamic or as up to second as what this allows you to actually gain. So the APM is actually positioned very well to become an application intelligence, customer intelligence, and actually become the next generation BI, especially for the businesses that are completely digitized. So if you're in the cloud and most of the applications are actually mobile web, and all of the interactions are happening online or in a digital form, APM is actually a much better way, especially through transaction tracking, to become your BI in a sense. So you actually take these dashboards and you can present to the line of business, even to CEO and product managers, to say, hey, here's what our customer journey is. Here's how all the critical business services behave. And here's how we're actually addressing our business requirements. And application developers play a critical role here, because they're the ones that actually make all of this happen. They provide the hooks, the instrumentation, and they implement the right methodology so that these things can actually happen. So in order for us to become actually more business relevant from the application side, we have to now derive business metrics that the business can consume directly through these types of dashboards. And one of the key important, and again, that I want to emphasize is this whole concept of data science. Data, if it's not being harvested, is a lot of it is useless. So today's APM tools store tons of data about all kinds of things that are going in the application. However, most of this data is fairly stale in the sense that it targets a fairly narrow set of users, such as developers and operations or DevOps. in a sense. But a lot of this data can actually be harvested for business. Now, in order to make this happen, we think that you need to have a way to get to this data without being like a SQL or expert, or without being a developer. So a data scientist should be able to come in and tap into this data that's being collected. And it's typically done through a query and analytics language. So one of the ways that you can kind of enhance the value of the APM tooling is to expose all of this data through a query and analytics interface. And a lot of it is also could be done by integrating with our language. And what that allows you to do is now expose a lot of this data to a whole set of machine learning and algorithmic interfaces that are already available. So you're kind of marrying data science and application performance to get that next level of intelligence. So this is just an example of what the query language may look like. It's pretty much an English-like way to talk to your data, but without having to write or without having to be a PhD in data science. So an APM tool, in a sense, or APM platform is going to have to expose this data, or the already tooling that's exposing this data in a way that makes it very consumable for a data scientist. So in conclusion, here's some important points. So APM has quickly evolved into the application and user intelligence. It does require a fundamentally different approach. You can't just store and sample metrics anymore and hopefully you get that resolution that you need. You need to be able to capture actual user interactions and transactions literally from beginning where the customer interfaces with your digital assets all the way to the end. If you have any hopes of figuring out how you improve your applications and what your customers are doing, and how do you increase your customer experience, but that needs in itself a completely different approach from the platform or from the tooling perspective. One is you need to combine the big data and streaming analytics, and you need to marry it with a data science in a sense. Why? Because you need to get all of that data, and you need to unlock it in the sense that somebody from outside can come in and say, hey, we understand the problems that we need to solve as a business, but we have all this data laying around. How do we make use of it? So you've got that advanced data science that has to come in and augment the data acquisition that we're currently doing through some of this APM tooling. Now, the paradigm has shifted to collect and analyze everything. Today, more and more, we see people are just storing everything, logs, metrics, transactions, user interactions, what they do on the mobile, what they do on, and obviously there's a privacy and other concerns there that is well beyond the scope of this discussion. But the basic premise of it is the businesses want to get insight into what their customers are doing so they can improve the quality of service. And transaction tracking, and again, in my view, is that one of the key techniques to do that. You need to be able to intercept things as they happen and pipe it through a platform that can analyze these things in real time as well as historical. And if you marry that with data science, that allows you now to take it to the next level where you could say, hey, we can address the DevOps type use cases from mean time to repair, mean time between failures and things like that. But then we can harvest this data for the business so they can now say, okay, here's what we need to do. Here's the improvements. Here's the features we need to build. Here's how we need to change things. And that feeds into the whole product management cycle. And then goes back into the product development and obviously back into the developer that actually goes out and implements these things. So that's kind of a high-level summary of what I was trying to say. And I guess, Billy, we can open discussion for some question answers. So we have a few minutes that we can address any questions that people have.
Yep, we had a few questions come in. One of the audience members asked, how is monitoring different from tracking?
Well, tracking is more of a, and again, is a technique. Monitoring is a feature in the sense that you can monitor transactions, but you're tracking these transactions, and you can monitor things that are going on. So they're not really, they're kind of complementary. They're not really oppose each other. So, for example, in the sense that you can monitor, for example, a service level agreement on the transactions, but you still have to track these transactions. So I would say that the tracking is more of a, and again, is a technique for capturing interactions rather than just sampling things as they happen. And then monitoring is really then looking at the metrics that you are collecting as part of that, and then applying them to some sort of standard, whether it's thresholds or some baselining and things like that. So monitoring is really a layer on top of it, and tracking in this case is really the way, and the way that I talk about it here is more a technique for capturing the data that otherwise is pretty much unavailable. If you just do sampling, you're not going to be able to understand, or you won't be able to get to that level of resolution. So it's all about resolution. So the tracking allows you to get to that level of resolution that you need to make these types of decisions, and the monitoring kind of layers on top of that.
All right. Another question that we have is, can this query language be used to forecast future prospects for the business?
Yes. So the query language, again, that's and I didn't obviously talk about specific implementation simply because different APM tools have different implementations for this query language. Some do, some don't. For example, in our case, we do. When you marry query language with machine learning, you can start doing forecasting. You could do predictive. You could do anomaly detection, and many other types of things, like, for example, automatic classification with Bayesian classifiers. So yes, and it really depends on the expressive power of any specific query languages so you're going to have to look at specific implementations. In our case, yes. So you could do, for example, what-if scenarios, what happens in the future, and for that, you need some of these advanced data science techniques to be able to make these types of this type of analysis. But in general, it depends on the specific implementation of the query language and the specific platform, application intelligence platform that's in question.
The next question is, what strategies can you use in order to not impact the app performance when you are retrieving the data for the running systems?
Right. So that's a good question. So there are some strategies you could use, like, for example, fire and forget. Now, what that means is you want to intercept as fast as possible, and your intercept can never do any network or specifically I/O. So what typically happens is your intercept has to take the data very fast, offload it typically into memory somewhere, and have an offline process pick that up. That way, you completely decouple application from any downstream activities that happen. So you have an intercept, capture, whatever that is, push it into a memory buffer in a sense, and then let go. If you typically don't do that, and then you have a synchronous path, you could potentially slow down your application, and the remedy could be worse than in a sense, can kill your application, right? In a sense, if your intercept takes and makes an HTTPS call and the remote side is down, now your whole application is hung. So you definitely don't want to do that. And when you're talking about transaction tracking, you definitely want to pay attention how this instrumentation is implemented. Because if you don't, it could potentially slow down your application, not by a few percentage points, but could slow down as high as 100 or a few 100% or worse.
Another question we have is, what's the most optimal way to track transactions for Java apps?
Well, a common technique is a bytecode instrumentation. That's a common way. And again, when we talked about granularity or resolution, you could use bytecode instrumentation to do tracing, meaning you're trying to optimize specific part of the code or maybe the whole application. However, bytecode instrumentation, and it depends on the level of resolution you have there, becomes very burdensome when you go into production simply because of the level of overhead. I mean, reality, bytecode instrumentation inserts basically bytecode or calls inside your method calls. So depending on, again, specific implementation of the bytecode instrumentation you use or specific vendor, you have to kind of look at it and say, well, what does it actually do? It kind of feeds into the previous question. All I could tell you is most of the vendor claims in terms of the less than 1% are most likely false, simply because it's based on some predefined set of criteria that they use. When you actually deploy it in your environment, you will see a completely different overhead. And simply because your applications are going to be different, you're doing things differently, the level of resolution is different. So you would probably looking at high single digits to double digit impact overall, especially with bytecode instrumentation.
The next question is, what is the overhead for transaction tracking?
Well, it's kind of, I think I've kind of addressed that in my previous. So again, depending on the implementation, I like to talk about overhead in terms of microseconds per intercept instead of percentages, because give you an idea. So let's say we intercept a transaction and the transaction takes 1 second. If you take 10 microseconds out of that transaction, the overhead is fairly low. However, what if my transaction is 100 microseconds and I take 10 microseconds, same 10 microseconds? Well, my overhead is 10%. So typically, I usually, and again, this is advise folks, do not look at percentages and actually ask for some numbers, like in terms of the time, because that way you can compare it to what you're doing and then make an assessment of what percentage that is versus take a percentage from somebody who tells you this is the percentage overhead, because that percentage is based on some benchmark that's not necessarily your application. So we're measuring in microseconds, and our specific overhead, for example, would range anywhere from a few microseconds to 40 microseconds, depending on the level of resolution that you're trying to get to.
And our last question is, what do you recommend for storing all the collected data?
So a lot of times, especially previous generation of tooling, store data in the SQL. That is fine typically for metric collection because you're doing sampling and aggregated metrics. So the amount of data is typically not that much. However, once you start doing logs and you start doing transactions, the volumes explode. So you typically would want to go to NoSQL simply because SQL it just doesn't scale as well and is probably more expensive. So you go to NoSQL. We prefer search-based or indexing type technology, such as, for example, Solr or Lucene, where you store hot data, and then for cold data, you actually want to break down your data stores into hot things. Basically, data store that's searchable, completely indexable, which means you can search for anything. And then for cold data, meaning for long-term storage, could be Hadoop or any other file system, as long as you have enough basically space to store data for as long as you want. But you typically want to split it into different storage. Otherwise, it would become too expensive to to index pretty much everything. And again, it depends on your budget, but we typically recommend to split into these two types of storage mechanisms.
Awesome. And with that, I'd like to wrap up, and I'd like to thank you, Albert, for an amazing presentation today. I'd also like to thank today's sponsor, Nastel, for providing the D-Zone audience with a great webinar presentation. And lastly, I'd like to thank everyone who joined us for today's presentation. We hope you learned something new today that will help you out in your developer career. Have a great day, and we'll see you next time.